Hello, we now see the introduction to CAN. What is CAN? CAN is Controller Area Network and developed by Robert Bosch in Germany in 1986. So, what is Control Area Network? It is a communication protocol. Communication protocol means to communicate between issues. A CAN protocol is used. For example, we can see in day-to-day life, computers. If computers communicate one to with each other, there will be an Ethernet cable. When you connect Ethernet cable, you can communicate between the computers. Similarly, in automotive field, CAN is used for communication between ECUs, electronic control unit, communication between electronic control unit. Uh, can Basically, I have attached a CAN 2.0 document. Which you can This is CAN 2.0 document, which is given CAN specification by Robert Bosch, Germany. And you can see the details of the acceptance. And you see it is a serial communication to more accept has led to requirement assigned of message identifier to communicate function standardized certain application can be it contains it provides the address range defined by 29 means extended. There is two types of formats. One is standard format and another one is extended format. In standard format there are 11 bit identifier. In extended format there are 29 bit identifier. Means identifiers, each message will have an identifier. And around 2 raised to 11, means around 2048 messages can be sent in a standard format, and about 2 raised to 29 and millions of messages can be sent in extended format. Can message a standard frame and extended frame can exist in a same CAN network? Yes, it can exist. There will be a translator or a dashboard available, which helps in having both CAN standard frames and extended format in same uh, same structure. CAN specification. Mm, and then we'll see uh, controller area communication, which efficiently real-time control with high level of security. With high level of security, this is the main mm, advantage of CAN. That is security, and it provide the surety of receiving message is very high in CAN. There is about for 100% of surety of receiving message, there is a 0.01% of uh, uh, loss of communication can be expected in uh, CAN is used in automotive electronics, engine control units, sensors, anti-skid systems, etc. are connected to bitrate. What is the bitrate of CAN? CAN bitrate is one maximum 1 Mbps. It can go up to 40 meters of length. It can go up to 1 Mbps. It is cost effective and built for vehicle body electronics. Uh, Initially, CAN implements compatibility and electric electrical features is the data interpretation of data transfer. It's into different layers: are CAN object layer, transfer layer, physical layer. Uh, and then about the CAN, it is a transfer layer protocol and controlling of there will be frame and a message, performing arbitration, error checking, error signaling, fault confinement. Fault confinement is main feature of CAN. Means if there is any defective node with a defective ECU which is communicating with CAN, then that ECU will switch off itself from the CAN network and do not disturb the entire network. If we without CAN, there will be one master dashboard will be communicating with many issues, and lot of wirings need to be done, and magnetic flux will be high, and there will be noise coming in different network. I'll show you how without CAN, how it will look without CAN. Say without CAN, there will be a dashboard which will be communicating with lot of issues. There will a lot of wirings will happen, and increase in number of issues, direct point to point analog lines communication, time consuming, and excessive amount of wiring architecture. Wirings will be too much without CAN, and with CAN there will be it looks very neat, simple, low cost, flexible, built-in error detection, robustness, and speed. These are the features available with CAN. So transmission freedom, scope of actual the how CAN communicates. CAN communicates through method called arbitration. We will see an explanation of arbitration. Arbitration is getting the priority of the bus. Means like in WhatsApp. In a group we are sending a message which will be seen by all the other people. It's like that with the node or issue which wins the arbitration will become transmitter, and every other issues becomes the listeners or the receiving end. And can transmitter will send the message, and receiver will receive the message. And it is configuration is flexible. Its features are prioritization of message, guarantees of latency time, configuration flex, multicast reception and synchronization, system wide data consistency, multi-master is the main feature. This any node can become, any issue can become master by sending the prioritized message ID. There is lower the message ID, the issue will win the arbitration and will send the data, and transmission of data happens between the issues. And multi-master error detection and signaling. There are different error detection mechanisms which we will discuss, and signaling these errors. There are some beautiful error detection mechanism is there, and automatic retransmission of correct. And if there is corrected message, immediately retransmission of message will happen. There is no loss of communication will be there. And distinction between temporary errors and permanent failures. And um, messages, and there is a functionality called flexible data transfer, through which can moderate can message can be message usually standard frame. There are 8 bytes of data can be sent, but in flexible data you can send more than 8 bytes, that is 16 bytes, 64 bytes, or 128 bytes of information can be sent. And flexibility, message multicast, data consistency, the baud rate of the CAN is very high compared to SPI, I2C, and other communications, RS to other communications. If you compare, baud rate of CAN is around 1 Mbps. And multi-master arbitration, safety, there is due to error detection mechanism, there is the safety of uh, messages are high. There is surety of the message being sent is very high in CAN. And uh, these things, and perform error detection mechanisms, and connections, single channel bus values, and uh, The frame format looks like this there will be start of frame, arbitration field, control field, data field, crc field, acknowledgement field, and end of frame field. Mm. uh, there will be two types of synchronizations happening in CAN. There is hard synchronization and soft synchronization. Hard synchronization happens at frame level. Soft synchronization happens at bit level. And the bits and more features of CAN if you look at to it. And there will be different. This is techniques available for the CAN. There are four types of frames. The types of frames are four types of frames available that we will see in detail. And about CAN message validation transmission, and putting this in detail, we will see how the CAN messages are happening. And fault it is a plug and play kind of work. Plug and play means any issue can be added or removed without disturbing anything in the network. So it is a plug and play kind of work can happen. And error detection mechanisms are very good in CAN. And uh, for and hard synchronization it is. And you can go through the pdf that I shared. It will be shared, it is shared by Robert Bosch, CAN 2.0. It provides the complete description of how the CAN communication happens. And we will see uh, 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 we'll see how the uh, CAN communication will happen. And CAN frame format. CAN frame format. This is the CAN frame format, which is you first starting bus will be idle, then first is start of bit identifier, then 11 bit identifier, RTR, ID, RDLC, data length is 4 bits, data byte is 8 bytes, CRC is 15 bit, delimiter and acknowledgement and delimiter and end of frame and interframe space. These are the formats of CAN. We'll see in detail. Thank you for this will be the introduction of